introduction is a worldwide renowned expert on fiber-reinforced concrete. He was actually the expert who brought this material into design codes and possibility for us to use that. And among his research interests and expertise, there is also the behavior of reinforced concrete structures under impact and explosion, these accidental actions. This technical committee 288 recently concluded this. We're writing, you had your last meeting yesterday, okay? And he was the chair. And this is an example, as he will tell us, also how different expertise from different associations, different contexts in the world bring towards a unified knowledge. So please join me in welcoming Mark.
Thank you, Liberato. I am also very proud today of your job. And okay, I have the pleasure today to show you the job that we did inside of this technical committee. I would like also to emphasize the reason why it was born and which were the main output that we were able to create. First of all, looking to the subject, the impact and explosion, in my opinion, everybody can immediately understand that are a tough topic to face as engineer. And the main reason for that is that, first of all, there is a relatively small knowledge, especially on impulsive dynamics, because everybody knows statics, or should know statics. Dynamics is quite well known, especially in a seismic region, but impulsive dynamic is very difficult and presents a lot of problems that are not even solved by the expert. Dynamic properties of construction material is also strongly debated. So we are wondering what really we can identify starting from the initial test. And this is, and I will tell you in a few slides, for instance, one of the main problems we discussed related to the diff. The diff is a ratio between the property in dynamic with the high strain rate and in static of a material. So we will discuss a little bit of it. And also there is a problem because at the end, as you know, the engineer has to solve the problem. So what he does when he cannot have a reliable model? He tries. So create a lot of empirical laws, but in many situations, if you don't understand fully the problem, you are not able to establish the right limit of validity of what you really empirically deduced. So these are the main reasons why, in our opinion, there was a need to create a committee on it, and in my opinion, RILEM could be a very good association to develop. I would like to remember, as also Nicolas did this morning, that RILEM is a réunion internationale de laboratoires d'experts des matériaux, but des laboratoires aussi. So also laboratory. And in my opinion, until now, we develop a lot the union and the network of the expert, much less the network of the labs. And this thought was discussed with the DAC when I was inside, and was a starting point that convinced me that this topic could be a good matter in order to try to restart with the idea that RILEM could be also a good network of lab. As you know, the goals of RILEM is also to test laboratory, as you can see here, the underlined part. We have to promote education and networking, and we need also a way to create discussion. And what I'm saying, what I see now is that everybody has much more money than in the past. We create a lot of experimental work. There is no discussion about it, so usually the test results are taken as they are. In the past, we have much less money, and when I started to work in research, there was always a discussion of our job, and so the results, the experimental results coming from one lab was discussed from everybody, because we had much lower number of journal, and so everybody could be updated and can use the results coming from that experience. Now we create much more, but sometimes we don't have the time to read all, and so there is a real problem for that. And for this reason, in my opinion, RILEM should try to return to create the network of laboratory, because instead to lose a lot of time to design a special device, as we need for such kind of problem, it's much better to use the device that is already ready in another country. And in this way, we can also share our knowledge on the problem, and we can promote the final knowledge on the topic. So at the end, we need to stimulate this idea and to produce at the end the state-of-the-art reports. Of course, also about it, we will discuss, because nowadays we don't have the best rules in order to do it. Sometimes you will be forced to produce many things only because every association would like to have a special publication on some special journal. Anyway, as you could see here, we started to think to create a network between laboratories. So we proposed in the DAC meeting of 2018 in Delft to create this new technical committee. And the main first goal that we denounced in the kickoff meeting in Milano on the 4th of July 2018 was to share the special equipment. So I invited people who had special equipment, and we would like to discuss and clarify which properties they would be able, or they could be able to identify with such kind of devices. And then there is also the need that, because I'm also a FIB member, I have the honor to be in the presidium of FIB, they need to create a new chapter in the Model Code 2020 on the subject of design of structures subjected to high strain load. And so immediately I thought that this could be also the good occasion to have a good number of experts that could verify if it could be possible to update what it was written in the 2010 on this subject. Well, so at the end, I started to create a group that was not only represented by people coming from RILEM. You could see underlined the initial number of people of the 3 different associations that were FIB, ACI, and of course RILEM. And I would like to cooperate with all of them because I knew very good experts in the 3 worlds, but unfortunately they couldn't belong to all the associations. So the first, in the kickoff meeting, I asked to the people to show the main problem they were interested, and also which kind of devices they could have in their own laboratory. So for instance, we had this situation for Belfast, Queen University, and you can see that there is a classical drop hammer. There is a double channel section, and the main problem they were investigating was essentially the impact against the bridge, so the problem of in this case, of the piers. And also they have some military devices, very power, but at the same time not so easy to use, because you know that when there is a military service, you need a lot of different guarantees in order to operate in this lab. Then we had also Professor Hochbolt coming from Stuttgart. He was not only a very good numerical expert, because everybody knows him, I suppose, because he worked on a microplane model. He worked a lot with Professor Bajan, but he reached a fantastic level in order to study and to investigate a real problem like the anchorage, for instance. And he was also interested to another problem that sometimes we have in the impact, that is a problem of fire and explosion. So, for instance, he did a fantastic job in India, trying to verify what happens if you hit a structure, so you create damage for the fire, and then you have also an impact. And I had the chance to follow this job as a supervisor of 2 theses of PhD. And he has also a good diagnostic lab, and so working on the small scale, he worked in Stuttgart. We have the fantastic feature that mainly Matteo Colombo is inside with us in this room, designed with the help also of Paolo Martinelli. So a shock tube which is able to apply a wave, which is a shock wave coming to a speed which is higher than 2 Mach, and is able to apply a huge local pressure, which was essentially something in the range of 1.5 megapascal, which is very huge, on a slab of about 50 centimeters, but changing as a final part of this equipment, you can also enlarge the test. And of course, this special device that we were able to finance due to an Interreg project on the safety in tunnels, it was also used recently to investigate problems like this. You know probably what happened a few years ago in Bologna. There was an accident where there was an explosion of a truck, and then there was a fall down of a bridge, so of a span of a bridge. And we are interested for the same reason to what happens perhaps inside of a tunnel, especially if the tunnel, as we have investigated recently, is under the sea, as in Norway we are trying to do. And of course we have also a recent drop machine, but this is not really special, it's a market one. We have also the contribution of TNO. TNO has a huge lab. They have a very good diagnostic. They have a small optical bar, and they have also the possibility to do some field tests, which are very interesting, because they can use some devices which is also in agreement with the military service. Well, anyway, we had the contribution of Dresden. Dresden created a huge mass able to use as the classical big drop tower facility. And it tested for punching a huge slab. So this is a very important device for the investigation on impact. And they have also a very important uniaxial and biaxial split Hawkinson bar that you can see here. Okay, it's not possible to see there, probably in this way. Yeah. And okay, so this is what they have in Dresden. And finally, we have also the contribution at the beginning from Madrid, where Alejandro Caldentey had the possibility to investigate real problem as engineer, but also full-scale test outside or inside to evaluate robustness and to evaluate the behavior after damage in fire. Okay, so at the end, after this first kickoff meeting, we decided which could be the final aim of our technical committee, and we decided to have essentially 5 aims. The first one was to coordinate a database for the special devices oriented to investigate impact and explosion effects on material and structures. The second one should be to introduce a state-of-the-art knowledge in a specific FIB bulletin, and so we did it. And now we have a bulletin that is ready, and we will submit in a few months. That works as a framework for the chapter that we will write, we wrote for the Model Code 2020. Then we had the possibility to discuss and compare different test methods to determine the parameters characterizing the high strain behavior. And we did this job with the ACI 544, so the 544, which is specialized on the behavior of fiber reinforced concrete used to protect the structure. And so they have created a very interesting state of the art, and we debated about it. And we had also the possibility to analyze the variables which more affect the structural effects, and this was essential in order to arrive to select the right procedure or the right level of design to adopt in different situations. And finally, to develop new practical recommendation and design criteria, and this is something that we propose at the end for RILEM, and we have just already written, and so we will submit in the few days the state-of-the-art to material and structures. As you can see, we did a lot of meetings, especially at the beginning, in order to clarify the best the aims. Globally, we had 21 meetings, 9 face-to-face, then there was pandemic, so we started to use online, and now I'm convinced that for the technical committee is a good idea to have 1 face-to-face, perhaps here, and 1 or more online, because otherwise the cost of our technical committee is too high. And if we look to the sustainability even of this type of organization, in my opinion, this is the best. We arrived to a global number of people, which was more than 40 people globally. A huge job was carried out by Ezio Cadoni, who compared as vice chair of this committee, of course, and is a very good expert in terms of high strain rate behavior of the material. And we started with the first output, so the idea to create a network of lab, and we produced in 2020 a first report where we were able to describe 27 different devices that could be useful to identify the high strain rate behavior of the material. We created a sort of a document where you can see for which kind of problem this type of device was used, with the reference, of course. And we created also an Excel file where you find all the main information that allow you to enter in contact with the people that really has a possibility to organize your job if you want to work with him for a special subject. You have to remind that in many situations, you create a fantastic device. It takes you 2, 3, 4 years. You use for 1, 2 years, then you lose the person who started this job, and the university in many situations needs a space, so you lose everything because you don't have people who can continue to work. So the network is very important also for this reason, because we need to use this type of device and to use in a very fast way, because sometimes when we started, we worked around 2.5 years in order to have the device ready. But if you can use immediately, of course, it's a different way, and so you can discuss immediately with the right person who is an expert of this device. Then, speaking about the output 2, so the FIB bulletin, we have a bulletin with 5 chapters, and this was a very important subject, because on this topic there are different ideas. And I would like to return mainly on one concept which is very important. First of all, we need to clarify together how to align this type of design to the new rules of model code, which is a design characterized by different level of refinement. So we should define which type of analysis could be correlated to the right level. And so this is not easy. This was strongly debated. And the second problem that we had, and there was also a strong debate inside, because there are people who are designers and people who are materialists, is what is really diff? Because if you think about even the simple constitutive law for compression, uniaxial compression in a cube, you know that if you look inside the mesostructure, you know that you can simulate all what happens. You have to introduce the heterogeneities. You can look to the material as a multi-phase material. And at the end, perhaps you are able to reproduce in all the details what happens, but always there is a scale to accept. And according to the model that we select at the beginning, we need probably to define a different diff. So it's not so easy to define a unique diff, because a diff is something that is able to correlate the model and the scale that you are adopting to the test that you are using to identify that property. So we discussed a lot on this. Even now there are some different opinions, but at the end everybody converge on this idea. And in the model code there is a huge change, because in the past the diff was essentially a two-branch equation. So there is a beginning in a semilog graph, a linear behavior, and then there is something that changed completely the slope, and nowadays is just linear. Why? Because some aspect correlated to the inertia was considered not part of the constitutive law, but was outside. And we discussed about it. And you can find different references inside of the FIB bulletin. The ACI 544 tried to put and to compare the results on fiber reinforced concrete obtained by different type of equipment. As you know, it's not so easy, because when there is also a fast dynamics, you have to know where energy essentially is oriented. No? So you don't have only energy inside of the specimen, but you could have energy inside of the support or other part. And so this is a real problem. And there is not nowadays a full, if you like, agreement on this point. But the state of the art that was published in ACI, in my opinion, and we reviewed, is quite interesting and try to be a real state of the art on the subject. In about the output 4, we had the chapter 30.2.3 that in the model code was able to align the different level of design and to discuss, for instance, that is not only a problem of strain rate, but sometimes it's a stress or strain rate, and it depends how you measure it. No? So this is something that was clarified. We had also the final report we wrote in the last months, and so we will have also a state of the art published on the material and structure that resumes the most important basic discussion that we did in the committee. We were forced also to diffuse a little bit our discussion and our knowledge on of the subject. So we participated to the Protect 2019. I remember to everybody that even this year there is another Protect in Singapore in August, which is a very important conference on it. We tried to organize also some summer school with the help of experts on impact and explosion. And this was, in my opinion, a good occasion also to discuss between us, with, of course, some good socialization times. And we tried to, at the end of this summer school, to create a test for the student. They should try to use what we taught them. And at the same time, we verify the ability to face a problem of impact, even for a simple case like a plate. And this is also something that could be interesting probably in the future to publish as a result of what we taught. We had the possibility to use this group also to share PhD theses together, so to create network. And for instance, in our group in LECO, we had the possibility to investigate with people coming from Norway the problem of fire and blast, and people coming from Dresden, the use of high-performance fiber-reinforced concrete material with mesh that are not metallics, in order to see which is the behavior to impact. And so we arrived at the end for the first just already to a journal publication, and in the second we are working on, and this was a lady who worked with us. And okay, so that's all. I would like just to remark that, in my opinion, we need to simplify more the possibility to work together. I already discussed yesterday that FIB, but also RILEM, I discovered, so this is very important, accept the reciprocity. So essentially, if I create a task group and I need an expert that comes from another association, he can have the possibility to work with us, sharing also the document. The only problem is that they cannot be the authors of the publication that goes as a RILEM publication if they are not, for instance, expert of RILEM. The same idea is for FIB, so I invite everybody, and especially the convener of the technical committee of RILEM, to share as much as possible the groups, because even if RILEM is very wide, in my opinion, is much more concentrated on the basic research, and we need to combine the basic with the design. And so this is, in my opinion, one of the main ideas that we have to force in our technical committee in the future. Thank you for your attention.